In this demonstration, we're going to have a look at a tetrahedron. We've already discussed that tetra is 4, and so a tetrahedron is a three-dimensional pyramid with 4 identical equilateral triangles, and being equilateral, all the sides are the same length. And so what we have here is a shape, and we were said was 22 centimeters long. So each of the edges is 22 centimeters, and we were asked to find the surface area. So to find the surface area, we want 4 times the area of each face. If you can find the area of one face, we're done. It's nice and easy. So let's have a look at one of the faces, bearing in mind that it is equilateral. So we have 22, 22 and 22. What we can do is draw in a perpendicular. Now the perpendicular leads us then to a right angle triangle with a height h and a base of 11. Using Pythagoras' theorem, we know that the long side squared is equal to the short side squared plus the other short side squared. And so 22 times 22, as you can see there, is 480. And 11 times 11 is 121. So if we subtract 121 from both sides, that will leave us 3, 6, 3 equals h squared. And then what we need to do is square root both sides. That will give us, no idea. Let's have a look. We've got the square root of, we've got 363, which is 19.1 approximately. So let's go with the height is approximately 19.1 centimeters. I think that will be accurate. So we have that the area of one face is a half times the base. Well, the base, don't forget, is 22 over the actual face times 19.1. which, when we calculate that, is half of 22 is 11 times 19.1 gives us 210.1. Sorry about that. 210.1 square centimeters. So the surface area then equals 4 times 10.1, 840.4 square centimeters. Alright, and we're done. That's it. Okay, now also I'm going to ask for the volume of the tetrahedron, which is a little bit trickier, because what we have to do is, if we look at the base, straight down at the base, then we know that the three-dimensional height, the perpendicular height, stands up from that base and is inside the 3D triangle. I'll try and show that with a diagram, but basically now what we're saying is it's the inside height, as it were. Okay, I'll call that big H because we've already used little h before. So we have to somehow find that over that. Now that's different to the last height. The last height was on the sloping face, whereas this height is, without having a three-dimensional model, it's difficult to explain, but it's the height from the base of the tetrahedron straight up to the top apex, the top point. And how can we find the length of that? Well, looking at it, we could do There are various ways of doing it, but we could find the green line here, which is that one there. Okay, but how do we find that? And once we've found that one, we know that the external edge is 22 centimeters, and so we can have 22 centimeters with the green line and with the red dashed line. So what we need to do is find the length of the green line. Now, just by looking, I mean, mine's only a sketch, it doesn't look like it's halfway at all. And so this could be a tricky little one. And so what do we need to know? How could we do that? Well, we could extend it down and make the right angle again. So we know the length of that because that's one of the faces. Let's call that one X, and then what we have, if I use one of those down there as well, so I'm just thinking this through in my head, I know that that's 11. And I will call this one Y, because that's also the length of the green one there. What do we know? Well, we know that X plus Y is the length of the height, the original height, which is 19.1. Which is 19.1. And we also know from Pythagoras' theorem there that y squared, let's draw the actual triangle. If I draw the triangle as it appears, then we have that. So that's X, that's a right angle, that's 11, and this is Y. So from that diagram, I can use Pythagoras' theorem and say that y squared, which is the hypotenuse, is equal to 11 squared plus x squared. Okay, so from here, from this left hand, if I take x from both sides, then we end up with 19.1 minus x, and that's the value for y. Okay, that's the value for y. I'm going to change my mind there, and I'm going to find a value for x. Now bear with me here, it's quite a complicated piece of mathematics, but we're doing alright. What I'm going to do is I'm going to define x. So if I subtract y from both sides, then x is 19.1 minus y. Now what I'm going to do is I'm going to take that value of x and I'm going to put it in here. So the yellow goes with the yellow. So I'm ending up with y squared equals 11 squared, which is 101, plus this new value for x. Okay, this is all very interesting because the computer's jumping around everywhere. Right, here we go. 121 plus the value of x is 19.1 minus y, all squared. Okay, so this is some work from that some of you may have done or may know about. This is now 121 plus 19.1 minus y times 19.1 minus y. Let me just put those values in there. So I've got y squared equals 121. Now this is the bit that you may not be aware of. This times this, this times this, this times this, and this times this. I'll show you that in a different way in a moment, but that will give us 19.1 squared is 364.81. We're going to take away 19.1y, and we're going to take away another 19.1y. We're going to add on y squared. And let's show you that over here in a different form, which is a grid form. What we're saying is it's 19.1 and y times 19.1. It's better off actually with minus y, like that. And let's just form a grid. So if I think about this as a multiplication, then I've got 19.1 times 19.1 in here. I've got minus 19.1y. I've got minus 19.1y again. And then negative times negative is positive. Y times y is y squared. So the four parts of this, 19.1 times 19.1, is 364.81. Take away 19.1y, take away 19.1y again, and add on y squared. Yeesh. Let's just get back to these colours again. So if I take y squared off both sides, then that goes to 0, and that disappears. So I end up with 0 equals 364.81 plus 121 is 485.81 minus 19.1 minus 19.1 is minus 38.2. Y. Okay, so if I add 38.2y to both sides, then I end up with 38.2y equals 485.81. And if I divide both sides by 38.2, 38.2 divided by 38.2 is 1, so that's 1y. And now I've got 485.81 divided by 38.2 divided by 38.2 is 12.7 approximately. So y is approximately 12.7 centimeters. It didn't jump around so much, I'd be very happy. But no matter. Now this is obviously very difficult for all of us, and possibly a little bit too hard to understand for some of us. Okay, and where we're ending up at is we've now found the length of the green line. We haven't got the volume yet because we need to find capital H, the red height. Okay, so we're going to have to do that using Pythagoras again. But at least we've got the bits now. We've got the 22 centimeters for the black outside edge. We've got the green line, which is 4.7, and we just have to find H. Bear with me while I put a new page in, if I can. It allows me to. Okay. Alright, so let's go back to what we've got. We have now looking at a different triangle. We're looking at the height h. We're looking at the length that we've just found, and we're looking at the outside edge of 22 centimeters. So here then, using Pythagoras again, 22 centimeters squared, so I beg your pardon, 22 squared equals h squared plus 12.7 squared. So h squared is 484, done that one before, 2 times 22, minus 12.7 squared, 12.7 squared, 161.29 is the square of the height. Let's have a look at that again then. So let's subtract those two. We've got 484, let's just do this, 484 minus 161.29 gives us that, and then if we square root that, we end up with 17.96. Let's call that 18. Okay, so rounding off, h is approximately 18 centimeters. So that's the height of the pyramid. Okay, so now to find the volume of the pyramid, of the tetrahedron, we're going to do 1/3 base area times perpendicular height. Well, we already know the base area because we worked that one out before, so it's 1/3 times, I can't remember it though, of course, base area. We said the area of each face, 210.1. So this is 210.1 for the area of the base times 18, which is 1/3 of 18 is 6, so 6 times 210.1 is 1260.6 centimeters cubed. That's the volume of the pyramid, of the tetrahedron that was on screen. Wow.